Okay students, so let me show you the example of sp3 hybridization. Okay, so this is methane molecule and this is the Lewis structure of methane. Alright, around the carbon atom there are 4 bonding pairs. So the number of electron group is 4. Right? Alright. Since there are 4 electron group around carbon, therefore carbon undergoes sp3 hybridization. And the molecular shape of methane, which has been determined by using Vesper, is tetrahedral. So when you draw the molecular shape of methane is like this. With bond angle (109.5 degree). Okay, so to describe the hybridization process of carbon atom, we start with the electronic configuration of carbon and hydrogen. So carbon proton number is 6, so the electronic configuration is 1s2, 2s2, 2p2, and the valence the electronic configuration of hydrogen is 1s1. Carbon has 4 valence electron which occupy 2s and 2p orbital. Okay, so now draw the valence electron orbital diagram of carbon atom. We start with ground state. So valence electron of carbon is 4, which occupy 2s. So 2s has 2 paired electron. 2p occupied with 2 unpaired electron. Okay. Around the carbon atom, you can see there are 4 bonding pairs which is aligned or equivalent with 4 sigma bonds. Okay, and to form 4 sigma bonds, carbon needs 4 unpaired electron, but from the valence electron orbital diagram it shows that only 2 unpaired electron is present. So in order to get 4 unpaired electron, 1 electron from 2s orbital of carbon is promoted to 2p orbital. So we continue with the next step, promotion of electron. So 1 electron from 2s orbital is promoted to available space in 2p orbital. 1, 2, now the promoted electron is this one. Okay, so before the sigma bond is formed, carbon undergoes sp3 hybridization. So how the sp3 hybrid orbital is formed? By mixing 1 s orbital with 3 p orbitals, right? So mix 2 s orbital with 3 p orbitals. So we will get a new hybrid orbital. So from the hybridization, 4 sp3 hybrid orbitals form. 1, 2, 3, 4. Sebab you mixkan 4. 1, 2, 3, 4. So you akan dapat satu set hybrid orbital yang baru, which is called sp3 hybrid orbital. Okay. So each sp3 hybrid orbital occupied with one unpaired electron. Okay. So to form the sigma bond, hydrogen will contribute its valence electron to be shared with carbon. But carbon undergoes sp3 hybridization. So carbon will contribute one of its electron which occupy sp3 hybrid orbitals to be shared with hydrogen. Okay, so maksudnya sekarang dekat sini, ini akan form satu sigma, satu sigma, satu sigma, satu sigma. Okay, so kita sekarang nak sambung dengan melukis orbital overlapping dengan menunjukkan pertindihan orbitalnya. Jadi sekarang bila kita nak lukis pertindihan orbital ataupun orbital overlapping of hybrid orbitals with pure orbitals, dia mesti align, mesti selari dengan molecular shape yang kita dah predict menggunakan Vesper theory. Jadi since dia adalah bentuk tetrahedral, maka bentuk sp3 hybrid orbitals of carbon itu mesti bentuk tetrahedral. Okay. One, 2, 3, and 4. So this is the hybrid orbital of carbon, which is sp3, 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 sp3. So there are 4 hybrid orbitals of carbon, iaitu sp3. And each sp3 hybrid orbitals occupied with one unpaired electron. Now, to form the sigma bonds, hydrogen will contribute its valence electron to be shared with carbon. So overlapping occur, which involve 1s orbitals of hydrogen. So there are 4 hydrogen atoms. So ada 4 overlapping. So this is hydrogen atom. 1s overlap, occupied with electrons, shared electrons with opposite spin. So now we have 1 sigma bond. Next, continue. 1s hydrogen overlap, okay, dapat satu lagi sigma. One s hydrogen overlap, opposite spin, the third sigma bond, and the last sigma bond. 1s hydrogen overlapping and shared electron and the sigma bond. Okay, so you have to draw it properly and clearly. Kalau boleh besar sikit supaya nampak overlapping tu dan kita nampak boleh dilabelkan. Alright, so you can see the orbital overlapping align with the predicted molecular shape, which is tetrahedral. Okay.